Hi, Prof. Charlie. On behalf of Group 2, I'll be giving a video presentation of Project 1, which is on the return distribution. Our group consists of members Hon Yuan, which is myself, Si Cong, Sergey, Ling Yi, and Jian Xiong. For this presentation, we'll be addressing on the question raised in the Project 1, which is 1. The distribution of simple and compounded returns and comparison with normal distribution. 2. Comparison between short intervals return and long interval returns. 3. Relation between the average simple return and the average compounded return. 4. Variance of long interval returns versus short interval returns. For the individual stock analysis, we will be focusing on the three main areas, which are descriptive statistics at different time interval, frequency distribution, as well as simple and compounded return. First, we start with the analysis of descriptive statistics of our sample. For returns on individual stock, both the mean and variance both increases from daily returns to monthly returns. The graph on the left shows that as duration increases, the mean increases as well. Likewise, for the graph on the right, the variance of the individual stock increases from daily, weekly, and subsequently to monthly computation. This characteristic is obvious since as the return accumulate, the volatility becomes bigger. Then we analyze the characteristics of frequency distribution for individual stocks at different time interval. From the graph below, a clear decreased trend in kurtosis exists as the interval gets longer, from around 7.4 dropping to around 2.4. The returns went from highly leptokurtic behavior for daily returns to one which almost approximates the normal distribution for monthly returns. We also compared simple returns with compounded returns at different time interval. It can be observed that as the skewness of nearly all the simple returns is larger than that of the compounded return. For kurtosis, there's a tendency, except in daily samples, that the kurtosis increase when transforming the simple returns into compounded returns. On the side of portfolio consisting of all the 30 stocks, in addition to similar relationship between mean variance and time interval found in the individual stocks, we find that the variance and mean of the portfolio at any time interval is lower than the individual stocks. This is mainly caused by the diversification of the stocks. Meanwhile, the kurtosis of the portfolio is usually even larger than that of the individual stocks. To further explore the property of the return data, we run a series of normality tests to determine whether the distributions of all these returns follow the normal distribution. The results of KS tests and SW tests are shown briefly in the table below. In the daily samples, none of the stock passes the significant test, rejecting the null hypothesis at 0.00. In monthly sample, the null hypothesis cannot be rejected for nearly 2/3 of the samples at 5% significant level. This applies for both simple and compounded return. The portfolio has gone through 6 tests. However, nearly all the samples rejected the null hypothesis of normality. From the normality test table, the statistics of the portfolio in the test are larger than that, most of those in the individual stocks. Meanwhile, in these test results, the difference of the results under the two measured are negligible. If we compare returns for short and long periods, we will see that the longer the period, the more the stock return distribution resembles normal distribution. You can see at the table that kurtosis for long period is smaller, thus it is closer to the normal distribution excess kurtosis, which is equals to 0. Also, the percentage of stock return distribution which can be considered normal increases as periods goes up to 1 month. Even though single stock returns distributions exhibit apparent trend, it doesn't apply to the portfolio returns. Hypothesis test shows that the portfolio returns don't follow normal distribution for any period duration. Now, we are trying to examine the relationship between averages of simple return and compounded return. If we assume that the continuously compounded return to be normally distributed, then the simple return is subjected to log-normal distribution. We have a fancy relation between these two returns averages. The average of the simple return equals to the average of compounded return plus 1 over 2 times sigma square. This relation is consistent with the stochastic model. Next, we examine all the 30 stocks return data and measure this relation by using error ratio, which is the difference from this relation equation over the return. As the results suggest, the daily and weekly returns hold this relationship strictly even though they failed the normality testing. The interesting thing happens in monthly data. The two stocks, AA and AXP, have significantly higher error ratio than others. The normality test shows that these two stocks' monthly return are not normally distributed. That is, saying other 28 stocks' return are closer to normal distribution. So this finding is consistent with the error ratios and what the theory suggests. If we make an assumption that the stock returns in every individual interval are independently and identically distributed, the exact discrete time process of the return xt at equally spaced time interval can be expressed as shown in the slides, which means that the variance of its increment is linear to the length of the interval. The first step will be to calculate the variance of simple return and compounded return. Then, we can compute the respective ratio between the monthly, weekly, and daily return to check whether the variance apply the same relationship as estimated. Table and graph shows that the most of the ratio between variance of weekly and daily return is about 4 to 5, and the ratio between the variance of monthly and daily return is about 16 to 21. Both are close to the ratio of respective trading days. Besides, the differences between ratio calculated from compounded return and simple return are not significant. Thus, we can get a tentative conclusion that the variance of long interval returns tend to be a constant proportion to the variance of short interval returns, and a constant proportion is decided by the ratio between length of the interval.